Today we're solving quadratic equations. Quadratic is just a fancy word that means the problems have x squareds in them. So if you look across the board, we have x squareds in all of these equations. Anytime there's an x squared in there, that's called a quadratic equation. Usually what you do to solve these is get the original problem to equal 0 if it isn't already, and then we'll try to factor. And that's the reason why this is in the chapter that we're doing, is that we're factoring all chapter lately, and factoring is the key to the whole operation here. So this first one isn't ready to go yet because it's not equal to 0. Okay, the first thing we'll have to do on these usually is get the problem to equal 0. So x squared is over here, plus 5x is over here. We'd like to collect everything to one side. So to get rid of the minus 6 that's in the wrong spot, we want to add 6 to do the opposite. So we'll add 6 to get it with its friends. Now we have a problem that we've been factoring all chapter equals 0. And our job is going to be to factor that. So we'll go x and x. With the sign of plus, we need to be same as the other one. So pluses. Multiply to 6, add to 5. So that would be 2 and 3. And now we're back at a spot where we were back in like chapter 2, I think we did these questions, and back to Algebra 1 days. If something times something equals 0, the only way something times something can equal 0 is if one of those somethings is 0. You could never get 0 as a multiply answer unless 0 was in the multiply problem. So for this piece to equal 0, you could either take this on a little side trip, x plus 3 equals 0, and solve it, or you could just think, what could make this little piece 0? What makes this little piece 0 would be a negative 3. We'll just always need the opposite number of what's showing. We see a plus 3 showing, take a negative 3. To make x plus 2 be 0, we would need a negative 2. Negative 2 would make this piece 0. If you don't believe me, take that x plus 2 piece on a little trip, let it equal 0, solve by doing some opposites, you'll get the negative 2 out of that. That last little step we did in chapter 2, you were given parentheses equals 0 stuff, and you just had to come up with the numbers. Today we have to do that in a different context where you factored it yourself. So this one, it's not ready to factor because it's not equal to 0 yet. X squared is over here. We need everything else to come join it. So to get the subtract 10x moved, we'd have to add 10x, do the opposite. To get rid of the minus 24, we could go with a plus 24. We're usually going to want to get all of this stuff to equal 0. Then we'll want to factor x and x. Both pluses, because when this is plus, they're the same as the other sign. And when it's same signs, we add to make the middle while multiplying to make the end. 6 and 4 would do that. And then we need to read one answer from each factor. X plus 4 creates a negative 4. X plus 6 creates a negative 6. So far, all of our factors were adds, so these were all negatives. If we did get a subtract factor, we would just get positives. We'd be doing the same thing. If you think you have the hang of that, try these next two. Pause the video, grab these next two, try it out. First thing we want to do is get this to equal 0. So with the positive 6x, I'd subtract that out of the way. With the subtract 8, I'd add that over so that things can equal 0. I like the x squared where it is. Just move everything else. Factor, xx as we've been doing. Again, a plus, so they're the same as this, but this time they are both minuses that I alluded to a second ago. When they're the same, we add to make the middle. So 4 and 2 add to 6. We'll multiply to make 8. And then we'll read off the answers. A positive 4 would make this factor 0. A positive 2 would make that factor 0. So that's our answers, 4 and 2. This one, when we factor, is going to be a little harder to factor, but we catch a break because it is equal 0 at least. So equal 0 is our friend. Factoring with the 2 in front of x squared, my first thought is I hope I could take a 2 out of everything, but that fails. So what we're going to have to settle for here is one of those factorings where we guess. With a plus, we know the signs are the same as the other ones, so we're not guessing at those. Those are both pluses. With 7, the only way we can get 7 is a 7 and a 1. So you could guess 7, 1, or you could guess 1, 7. 1, 7 is the winner. I know that's the winner because that makes a 1x. Those make a 14x. Together, that's a 15x. That's the only way you could get a winner. Answer from this would be a negative 7. X plus 7 creates a negative 7. For factors where there's a number in front of the x, we're going to get fractions for those. So for the first time that happened today, let's take this on a little trip. Take the 2x plus 1 on a little trip, an open space where it could equal 0, and just solve that. Subtract the 1, divide by the 2, and we're getting that answer. If you want a shortcut, always what's going to happen is switch the sign of this, as we have been, to create a negative 1. But the number with the x will always end up making a fraction bottom, so negative a half. One more of those. Again, it's equal 0, so we caught a break. We're just going to need to factor. So if you want to get more out of this, pause the video, factor it yourself, see if you can do this without me. With 4x squared, we're going to need to guess. We could either go 4, 1, or we could go 2, 2. I'll usually go 2, 2. I'll usually go with the more equal amounts of numbers and not do the 4, 1 choice, but not here. I'm not going to go 2, 2 because that's an even overload. If I make these both evens, there's no way I'll ever be able to make an odd. So this has to go 4x versus x. Signs with a minus, I'm just going to go different signs. I'm not even thinking about it. I'm just going to throw a guess down there. I have no idea if that's what I want or not. With 12, I could go 12, 1, which I'll shy away from. Unless this were like super humongous, then I would start with 12, 1. 2, 6, I won't even try 2, 6, because 2, 6, that's both evens, and I've got to get an odd. So 2, 6 is hopeless. I'm going to hope for 3, 4. I won't even try 4 here. If I tried 4 here, I would have a GCF. If these both have 4s, we'd have a GCF situation. And I can't have a GCF situation in the answer if I didn't have a GCF situation in the problem. The problem didn't have a GCF, so the answer, no way could it. So 4 would be hopeless here. So I'll go 3, 4, and then hope for luck, and let's see how lucky I was. This would be a positive 3x. This would be a negative 16x. Together, that is a negative 13x, and I'm good. Where I got lucky was on the signs. I wasn't trying to strategize, I just guessed. If my signs were backward, I'd have had a positive 13 and then just had to switch them back. Reading off 2 answers. The x minus 4 is easier. That just gives us a 4. Anytime there's a plain old x, just switch the sign. This will have to make a fraction. If there's a number with the x, we're going to get a fraction that's going to have the 4 on the bottom from this 4. And then the plus 3 is going to turn into a minus 3. If you don't think you can trust yourself to remember the shortcut of switch sign, number goes on bottom, just anytime you need to, take the factor you're looking at on a little trip, let it equal 0, and just do the opposites. Subtract 3, divide by 4s, you can turn it out that way. I'm not sure in the homework if get equal to 0 and factor will always work. I can say in life that won't always work. In the homework it might always work. Some of the problems though will go easier in the homework for sure if you go with one of these 2 strategies. So if there's not a number in the question, like we have 5x squared, we have some x's, but we don't have the plain old number, what you're going to want to do there for factoring is take off an x, or maybe more than just an x. And when you do that, I guarantee you 0 will be one of the answers. So as soon as I see this question, I know that my answers are 0 and something, because this didn't have a number. As soon as I see this question, there's not a number there. I will guarantee you the answers are 0 and something. It's just a question of what the something would be. We still would want to get these equal 0, so that advice still applies, so maybe I should put that on there. If there's no number, still get it to equal 0 before you factor off the x. But for this, I would not just take off an x, I'd also take off a 5. If we take off a 5 and an x, it would leave an x, a minus, and a 1. Because we took off the x, 0 will be an answer. If x were 0 and we multiplied this stuff, it would make everything equal 0 in the end, and that's what we're trying to accomplish. The x minus 1 will give us the other solution, which is a positive 1, the same way we were doing the earlier one. This, I wouldn't just take off an x, I'd also take off a 2. If I take off an x and a 2, it would leave me with 1 plus 2x. The x we took off is going to give us a 0. And as an aside, if we took off an x squared, x cubed, x to the fourth, if we had taken off any power of x some other day, powers of x still make zeros be answers. Taking off a number is meaningless. So if I went back to this question and we had also taken off an x, 0 would be in the answer list. X squareds, x cubes, x to any powers, 0 would be in our answer list. But if I took off like a 2 or a 3 or a 5 or a 10 or a million, or I took off any number in the world, that wouldn't have done anything to our answer list. That would have just been a worthless distraction. Back to the task at hand. This x gave us a 0 answer. This 1 plus 2x is like written backward from how we usually write things. Okay, you probably prefer that to look like 2x plus 1. If that looks like 2x plus 1, we can do our little shortcut fraction thing. The number with the x goes to the bottom, the other number does a sign switch. The same trick applies here. You just, again, you'd have to notice it was out of order. Sign switch the regular number for the top, take the bottom, and do that from the number with the x. If you find any of that confusing, just take the thing that confuses you on a journey to an open space where it could equal 0 and solve it. Subtract 1, and then when you divide by 2, you're going to get what we got. Last little bit of notes, another special choice is some of the problems won't have x's. If the problem doesn't have x's, I would not get it equal to 0. What I would do if the problem doesn't have the x term and it just has x squareds and plain numbers without the x's, I'd get the x squared alone, and then I would do a square root. And I will guarantee you, your answers are going to be two numbers that are opposites of each other, like positive 8, negative 8, positive 10, negative 10. You're going to get a situation like that. So for this one, I would add the 125 to get the x squared more alone. So 5x squared would equal positive 125 if I add the 125 away. I would divide then by the 5. If I divide by the 5, I'd get 25. And now the x squared is completely alone. Now I'm going to do the square root. If I do the square root of 25, it's not just 5. It's also negative 5 that works. Because 5 times 5 is 25. But negatives times negatives also making positives. Negative 5 is just as good of an answer as positive 5. And we knew going in, the answers were going to be opposites. If you want to use a math symbol and be a little fancy with this, you can write that also like this. This is another way to describe these two answers. It's positive or negative, whatever. So this question, as soon as I see it, I don't see an x. I know that my answer is going to be positive or negative, something. This question, as soon as I look at it and I don't see an x, I know that the answer is going to be positive or negative, something. If you have the hang of this, maybe pause and try it yourself and see. For this one, I would look to add the 30, so that would equal a positive 30. I would divide by 6, so that would be a positive 5. And then square rooting 5 is a little awkward. It doesn't really go. If you try to do the square root of 5 and use your calculator, it's an irrational number, like pi. It's a decimal. It goes forever. Never ends, never repeats, fills your whole screen. There's no kind of pattern. So instead of writing that, just put the square root of 5. That's the simplest way to put that. Square root of 5 is square root of 5. For this one, we look to add the 25, so 9x squared is alone. Add the 25 out of there to do our opposites. Then to get the x squared alone, we would divide. 25 divides by 9, and I wouldn't go decimal for that. I'd go fraction. It's just simpler looking. And then we'll do the roots. And we catch a break here because we can do these roots pretty well. Square root of 25 is 5. on the bottom, the square root of 9 is 3, and we're good. So homework off of this is going to be page 236. On page 236, we're going to skip the third column, which is skipping the multiples of 3, and we work the 1 to 39 zone. I guess actually 1 to 38, because 39 is one of the ones we skip. So 236 today, skipping the 3s, going up to 39. Next time we see each other, it's important that you have absorbed this, because the last lesson of the chapter, which is the next lesson, we're going to have word problems where we're going to have to do this. We're going to have to make the problem ourselves from a paragraph and then do this again. So next lesson is like an instant replay of this, but in a word problem setting where you have to do the creation. So make sure you put some time into this to make sure we're good. The other thing we're looking to do next time we see each other is the quiz that we rehearsed yesterday, where you have to memorize the top 8, factoring how to do it, and then there's 9 questions at the bottom. So if you're not so good at that, maybe start to memorize those top 8 answers especially, and we'll see each other soon.